It's a special privilege to be with you this evening. I have much to say to you by way of introduction, but I don't have any time, so just know I'm glad to be here. Thank you for the invitation. I have much to talk to you about, so we're getting right into it. Thank you for being here with us tonight. This is a series of 3 lessons, and I'm standing down here because the elders have told me I can teach this like a class. So welcome to my class. Blessed assurance is the theme of this series. And of course, as Christians, we're looking for blessed assurance concerning God. And the subtitle of this series speaks of Lord of creation and the God of salvation. And we all know that the Word of God reveals about both of those things. So I want to start tonight with some passages from the Word of God. Christians believe the Bible is God's revelation, and it speaks to both aspects of the theme of this weekend. So let's turn first to Psalm 19. And I hope you have your Bible with you. If you don't, you can just follow along. But Psalm 19, verse 1 says, "The heavens declare the glory of God, and the firmament shows his handiwork. Day unto day utters speech, night unto night reveals knowledge. There is no speech nor language where their voice is not heard. Their line has gone out through all the earth, and their words to the end of the world." The psalmist of old said, there's testimony about God, the Creator, in the natural world. In the New Testament, Romans chapter 1, if you want to turn to that passage, that's really our theme passage for this series that I'm doing. Verse 20 says, "For since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." That passage teaches, even though God cannot be observed directly, you can see him in the things that are made. And it's the famous argument from design. If there's a design that you can observe, it points to a designer. So both of these passages in the Bible, Old and New Testament, and numerous others, testify that God's the Creator and that there's evidence of him in the natural world. So my appointment in this series is to turn with you to God's other testimony. He has a powerful testimony in the natural world. Both Psalms and Romans teach that. And so for the time of my lessons tonight, tomorrow night, and Saturday night, I'm going to ask you to follow me into the testimony of the natural world. I like to call it God's other book, because he has more than one testimony. Certainly his testimony is clear in the Bible, but the Bible says he has another testimony. So for the rest of our time tonight, I'm going to turn this book over here, and we're going to spend the rest of our time looking at God's other book. I hope nobody takes any offense at that, because God has a powerful testimony independent of that book, which I'm convinced is the Word of God. And our other speaker is going to spend his time testifying from that book. I'd love to do the same. But I also love to speak to you about the testimony of the natural world. So, our title for tonight's lesson is Christianity and Science, Conflict or Coherence. I got that title from this little book right here. In fact, it's exactly the same title, by Henry Schaeffer. This is a class, so you're allowed to interact with me. So I'm not going to pick on any individuals, but you are allowed to interact. So I'm going to ask you, has anybody ever heard of Henry Schaeffer? Okay, a couple of you. Henry Schaeffer is only one of the most world-famous chemists, and I don't blame you if you've never heard of him. He got a degree at Stanford. He is a world-famous chemist because of the things he's done. And you can read this text and find out more about that. The reason I use his book is because this book is full of examples of scientists of first degree throughout the centuries who were firm, convicted believers in God, in Jesus Christ as the Son of God, and in the Bible as the Word of God. And there's way more in this book than I'm going to get to talk to you about tonight, so I want you to be aware of it. This is one of a number of books we're going to reference in this series. And there's a bibliography available even now, thanks to Eric. And you don't have to write all these down because every one of them's in it. And there's a lot more that are in that bibliography, but the best ones have like 4 stars by it. So Dr. Schaeffer lists a whole bunch of folks who are well qualified, who are believers. But modern science has presented many challenges to believers in God. And many of those believers, which we're going to talk about briefly, in the old days, would speak out very publicly and openly about their convictions about God, Jesus, and the Bible. But I will tell you, since the Age of Enlightenment, the 16 to 1800s, things have changed dramatically. And you live in a time in which modern science has presented us with many challenges. And there are many scientists who've come to the position that you cannot harmonize belief in God with science. They are incompatible and they cannot be reconciled. I could read you quote after quote from modern day scientists who say that very thing. And one of the reasons I spend time doing this in my life is because I went through a challenge myself in facing situations as a college student in my early teaching career, and as I was going into the chemistry and math field, where I was personally challenged. And in many instances, I didn't know how to deal with that. So I like to give young people, especially in our time, but all us old folks too, foundations for our faith that God is creator and that the science does not conflict, but conforms. And there is no conflict, there's coherence. So that's what we're going to be talking about this series. So here's one of my favorites. Before I do that, I want to read you a quote here, from a famous scientist and historian named Dr. Wesley Allen. The conviction that all phenomena of nature should follow a master plan because God designed the universe according to his perfect character was a central motivation for Copernicus, Galileo, Kepler, and Newton, and many, many others. I hope you heard that. Anybody in this class know who Johann Kepler is? Hardly anybody. Dave knows because he's a science guy. Johann Kepler's not as well known as, say, Isaac Newton. How many of you know about Isaac Newton? Well, everybody. But Kepler is famous, especially for his work in astronomy. And he was a brilliant scientist and a mathematician par excellence. I wish I had the time with you in this class to explain to you how math is the language of God, because that's what he said too, and it's the truth. It's orderly, and it speaks to someone who designed this. And if you can describe it mathematically, you've only reached the peak of what man can do. So here's what Kepler said. I was merely thinking God's thoughts after him. Since we astronomers are the priests of the highest God in regard to the book of nature, it benefits us to be thoughtful not of the glory of our minds, but rather above all else of the glory of God. And then he would say to you, if you were in his class, you need to learn that we have discovered the orderliness of this amazing universe, and God speaks to us in the language of mathematics. And may I say to you, class, he spent a lot of time using logarithms. You remember this? Your favorite thing in algebra? Extremely complex way to do things, but that's all he had. And he made remarkable discoveries with that. Well, much more could be said about Kepler, but I turned to Isaac Newton. That's the reason you raised your hand, is because most everybody says that's the greatest scientist that ever lived. And let me tell you some reasons why. He invented the calculus. Well, how many have had calculus in here? A few of you. I know it was your favorite subject. And if it wasn't, it's because you didn't have me. Because it's only the most important class you'll ever take if you're a math science person. And you better understand the concepts, right? Yes. My fellow math teacher. He not only learned how to use it, he invented it. And he formulated the classical laws of motion on which is founded all of physics of the modern time. He invented and applied the universal laws of gravitation, which we'll come back to a little later in this lecture. He also built the first practical reflecting telescope, pioneered studies of light and optics, incredible studies on light and optics. And while I'm here, let me just recommend another little book to you. It's a very recent book called The Children of Light by Michael Denton. And it's a testimony of how much we depend on light. And can I just tell you one interesting fact? The light that comes to us from the sun, that is not filtered out, is mostly visual to our eyes, and the infrared spectrum, parts of it. And out of all the electromagnetic spectrum of things that are promoted that way, visible and IR light is one little teeny line out of all of that whole spectrum. And that's how we survive here, folks. It's one of thousands of examples of how one little tiny piece of what's available is what God chose to use. Fascinating book. Newton is one of the greatest students of light ever lived, and opened the door to many things we've learned about it. And theoretically determined the speed of sound, and we could fill that thing up 16 times with things he did. That's why he's the most famous. And here's what he said in his most famous work, the General Scholium to the Principia, 1713. Though these bodies, speaking of our solar system, may indeed continue in their orbits by the mere laws of gravity, yet they could not by any means have first derived the regular position of the orbits themselves from these laws. Thus, this most beautiful system of suns, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. And it is said, ladies and gentlemen, that Isaac Newton spent more time studying the Bible than he did the sciences. He was absolutely convicted that God is creator, and partly from his evidence from the natural world. Don't you love it? In the early 1800s, this book, Natural Theology, or Evidences of the Existence and Attributes of Deity Collected from the Appearances of Nature by William Paley, was the standard work in colleges. If you went to college in Europe in the early 1800s, Paley's Natural Theology was expected. When Marilyn and I first went to Florida State, there was one class they made every student take. It was the study of man. They thought it was so important, everybody had to do it. It was totally evolutionary, of course. But in those days, you had to study why you should believe that there was a God who created. And that famous book started with the famous watchmaker argument. Have you heard this, class? Most of you are nodding, so I'm not going to take the time to tell you that. But it's just this. If you came across a rock and kicked it over, you might ask, what in the world, how'd that rock get there and who cares? But if you kicked over the rock and you found a watch, you wouldn't ask the same question. You would say, somebody designed that. It had so many features that looked like there was intelligence behind it. And that was the start of his class. And then he proceeded to tell you all the things in nature that point to much more complex and amazing things than watches. And that surely there had to be a designer for that. Well, what's happened in the last 200 years? I'm going to tell you a brief story about that. But in our time, in 1980, Carl Sagan published the first, most famous science series on television called Cosmos. And the original statement in that series was, the cosmos is all that is, or was, or ever will be. And ladies and gentlemen, that statement is not science. That statement is a philosophy that he believed in very strongly. You couldn't anymore prove that from the sciences, but that's how he started his most famous physics series. And it swept the world with its visibility. And that series has been re-upped by Neil deGrasse Tyson, by another Cosmos series that explain things the same way, that all there ever is or ever will be is nature, and nature produced everything you see here, doesn't need anything outside of nature. That's foolishness. And I can tell you, when I was at Harvard University and Carl Sagan was teaching there in the 1960s, I didn't have him as a student, but the people who were teaching me were his cohorts and believed the same way, basically. The rule was, if you're in a class and you expressed belief in God, they would say to you, you better get over it, because the more science is learning, the less you need God, and there's going to come a day where you're going to be completely embarrassed that you even admitted such a thing. And I'm telling you, class, the exact opposite is the case. And that's how I want you leaving this 3-lesson series, and don't miss any of them. Because the evidence is overwhelming. And when we get finished, we will have not touched the hem of the garment. But I hope that when you walk out of here at the end of that 3rd lesson, Saturday night, that you will be stupefied at the amazing things we've learned about our Creator. Sagan had no use for God. And his cohort, Richard Dawkins, who's still alive, Sagan passed away several years ago, and I suspect he knows right now a whole lot different from what he taught. But Richard Dawkins, British evolutionary biology and biologist and author, professor of public understanding of science at Oxford University. Folks, they appointed this man to be the professor who tells you and I, us common folk, how the sciences work and what they mean. Please don't miss that. And the reason I quote him several times is because he pretends to be the representative of science to the public. I would say he's a sad representative in many respects. So here's what he says. In his book, The Selfish Gene, 1976, he said, faith is blind trust in the absence of evidence, even in the teeth of evidence. It's a process of non-thinking. Thank you very much. There is no believer in God, class, anybody that I know, who believes that faith is based on no evidence, or that goes against the evidence. No, sir. And by the way, the Bible doesn't teach that either. The Bible teaches you should have evidence for what you believe and stand on the basis of that solid evidence. So he's completely wrong about that. And folks do not like in the evolutionary band for you to use the word faith at all. There is no faith, they say, in ours, which is science. Faith belongs to religion, which is why creation doesn't belong in the science classroom. Well, they're as wrong as they can be about that. But it gets worse. In his book, The God Delusion, in 2006, he says, if this book works as I intend, religious readers who open it will be atheists when they put it down. Why in the world is a science professor trying to help make you an atheist? It's because of his narrow-minded view. And look what he says. If you're in this room tonight and you're a believer, here's what he thinks about you. God is a delusion, a psychotic delinquent invented by mad, deluded people. I say that's pretty ugly. That is not helpful, and it's completely wrong. And I wonder if he would say that to Isaac Newton face to face. and many other scientists who are completely in disagreement with him. No, God is no delusion. The evidence for his existence is overwhelming, even though he cannot be observed directly. But how this has happened over the last 200 years, how did things change so radically? It is the case, class, that the scientific method of modern world was invented during the days of Christianity in the Western world, and many would argue, were it not for Christianity, it would not have been developed. Because Christians believe there's orderliness to God's world. And science has to depend on orderliness if it's going to have any results. So how did that happen? We'll briefly run through a history of science. Pierre Simon de Laplace lived right after Newton, and he thought he was the next Newton. And he said nature with its matter, energy, and forces could produce and maintain our solar system. There's no need for a God hypothesis. Remember, Newton said, surely the laws of gravity could keep those planets in motion, but they couldn't have put them there in the first place. And this man says, no, they were not only produced, they also produce and maintain just by natural forces. You don't need God. And that came to be a popular thing through the 1800s. And Charles Lyell, in Principles of Geology, an attempt to explain the former changes in the Earth's surface by reference to causes now in operation. The present is the key to the past, said Charles Lyell. You don't need any God to explain geological formations. All you need to know is how things work now and just extend it out billions of years. So you don't need God for geology. And then in 1859, Charles Darwin published his famous book on the origin of species by means of natural selection. Have you read the subtitle to that book, class? Or The Preservation of Favored Races in the Struggle for Life. I'll let that sink in. And I want to tell you the destruction that's been wreaked upon mankind as a result of this man's theory, which has been bought hook, line, and sinker. There's no way to measure. We'll talk a little more about that in future lessons. This book has impacted the world more dramatically than any other book than the Bible, other than the Bible. Because it's changed the way people think about where we came from and what life's about, not just the biology. No need for a designer to account for the origin of species of life, said Darwin. Natural selection acting on natural variation accounts for the appearance of design. It looks like it's designed, but it isn't. Nature did it by itself. And then some years later, O'Perrin and Haldane came up with the hypothesis that you don't need God to produce life from non-living things either. So folks, over the period of about 200 years, every facet of science supposedly eliminated the need for God. So that now, many scientists would say, you cannot harmonize belief in God with the results of the science that we've uncovered. They're incompatible. I'm pausing on purpose. And if you're in my class, you know I just said something important. And I want it to sink in. I say the argument for design needs to be revisited. And here's some reasons. Stephen Meyer's written 3 books. I recommend them to you very highly. Stephen Myers is one of the leaders of the Discovery Institute up in the state of Washington. They put forth much fantastic information about intelligent design and why you should believe it from the sciences. No reference to scriptures are necessary. The sciences speak loudly. So his trilogy is The Signature in the Cell. We'll reference that tomorrow night. Darwin's Doubt, which has to do with the origin of life itself. And it's a fascinating book showing why there's no way non-living things produce living things. And then this one, which I want to reference tonight, The Return of the God hypothesis, a takeoff from Laplace, who said there is no need for the God hypothesis. Meyer says what we've learned in the last 100 years is sufficient to overthrow the statement of Laplace. The evidence has become overwhelmingly strong from science. There are 3 great discoveries in your century since you've been alive that ought to turn this thing around. The first one is the universe, space, matter, and time had a beginning. Did you know, class, that most atheists throughout the centuries don't believe matter had a beginning? It's eternal. It's always been here. The very notion that matter had a beginning is very disruptive to some of those fellows. And they'll say it. Because if matter had a beginning and time and space, who started it or how did it get started? You can't count on it because it wasn't there. It's a problem. The evidence from the natural world points now to a beginning. I'm not discussing that in this particular series. There's lots of material in the bibliography if you want to dig into it. Secondly, the universe, our solar system, and Earth are remarkably fine-tuned to support life on Earth and have since the beginning. This is called the fine-tuning argument, and I am going to talk about that one with you tonight for a few minutes. And I hope to blow you away with the little bit of time we have. This evidence has become compounded in the last 100 years. And then, thirdly, even the simplest forms of life at the biochemical level contain massive amounts of digital information being used to produce and maintain an untold number of molecular machines and complex processes. Well, I lost you there, didn't I? Little bitty things at the nano level, we have learned, have all kinds of complexity. They're loaded with information. And class, from the evidence of the scientific community, where does information come from in every case? Intelligence. Period. And there are machines, amazing machines. Come back Saturday night. We're going to talk about that. So let's talk a little bit about fine-tuning. Paul Davies is an atheist, or at best an agnostic. He's not a believer. But in his book, The Goldilocks Enigma, Why is the Universe Just Right for Life? He says the following. One of the most significant facts, arguably the most significant fact about the universe, is that we're part of it. And I say, amen. So how'd we get here? That is an amazing question. They believe, class, you got here by natural causes over millions and millions of years. No God needed. Davies says there's some things about that that don't add up. Everyone agrees that the universe looks as if it was designed for life. I say amen. And then he says in his article on the anthropic principle, the really amazing thing is not that life on Earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge and would be total chaos if any of the natural constants were off even slightly. So let me say it this way in summary, and then we're going to talk about some specifics. If you had a machine, great big huge machine, this is a universe-making machine, and it has dials on it. Let's say there's 500 dials. And every dial has to be set just right or you don't get a universe. Certainly not one with life in it. And each one of those dials has to be right within a very, very, very small range. And that's exactly the way it is in the natural world. And everybody knows it. The question is, how is it that that's the case? And my answer is, of course that makes sense if there was a God who designed us with that kind of mathematical specificity. There's no reasonable way to define that from the sciences and describe how that is the case. But it is the case, class. Don't you believe what I say? You go check for yourself. In the 1960s, when I was at Harvard, we had discovered some 12 characteristics of the cosmos and our solar system that were fine-tuned to make human life possible. 12 or so. This field was just getting started. By 2020, there have now been at least 50 books published on this subject, on the anthropic principle. And Hugh Ross and his staff of scientists at Reasons to Believe cataloged over 800 fine-tuned characteristics as essential for any potential human life site on the observable universe. Now, people disagree with his 800. But I'm going to tell you, class, there are hundreds of factors that all have to be just right, or you wouldn't be here. So, class, for the next few minutes, I'm going to ask you some questions. The answer to the questions is just right. Okay? That's the answer. So when I ask you the question, you already know the answer, and you're going to say it out loud. Because some of you are falling asleep, and I don't allow that. Okay? And if it gets worse, we're going to stand up. You don't go to sleep in my class. Foundational. Just rights. I think my favorite book in this lecture is this one. It's called God's Crime Scene by J. Warner Wallace. J. Warner Wallace was an atheist. His daddy was an atheist. His mama was an atheist. His whole family were atheists. He grew up just like his daddy to be a detective in the police. He was a cold case detective. You know what that means. That's one that's kind of gone, they didn't solve it. It's been sitting around a long time. That's the hardest kind of case to solve. And so he decided he would look into the universe as if he were involved in a cold case detective situation. So I want to share with you just a little bit about how they do that. So I'm looking at chapter 2 in this book. And by the way, every chapter in this book, this is a good one you need to buy and read to your kids. They'd love it. Chapter 2 is called Tampering with the Evidence. Tampering with the Evidence. And every chapter is based on a case that he solved. So I'm going to tell you the end of the story here before we get to it. He solved the case in chapter 2, and the guy was convicted of first-degree murder. Nobody saw him do it. It was all circumstantial evidence, and the jury convicted him unanimously of first-degree murder because the evidence was overwhelming. And there's very much like that in our study of the universe. Helen knew something was wrong when her daughter Carrie failed to answer the door. It was a bright summer afternoon. Carrie said she'd be home, and her car was parked in the driveway. Helen tried to peek in through the living room window, but the curtains were unusually drawn. Carrie never locked the back door, but when Helen walked into the backyard of the old home, she found the door locked and all the windows closed. That wasn't like Carrie. She never closed that badly worn back window. Helen began to panic. She knew Todd and Carrie had a tumultuous marriage, one that included physical violence. Todd had moved out, but Helen was still fearful for her daughter's safety. You see, the couple had a child named Lexi, but the violence had only intensified since she was born. A week ago, Todd had threatened to kill Carrie, and just last night, Carrie confided in her mama there had been yet another fight. When Helen could not get Carrie to answer the door, she called the police. So that's the beginning of chapter 2. And the rest of it was how he went through the case and convicted Todd of first-degree murder. He said, here's how we do it, class. We use foundational information first. Stuff that affects everything else. Well, one of the things that was foundational in that case was Todd and Carrie's relationship, wouldn't you say? It affects everything. And threatening violence. But there were some other interesting things. And we'll talk about that just briefly. Second is regional. In that case, is what was around that house? And what's going on? Third is locational. What was going on inside the house? And he said, we try to decide when there's been a death whether things inside the house can account for it, or did somebody have to come in from outside and tamper with things? So foundational, regional, and locational layers of circumstantial evidence to unfold the case. So just for the sake of time, I've written myself a few notes here, and this is your case. You're the jury class. Foundational. Every crime has a backstory. Foundational conditions in this case, Carrie and Todd's relationship history was terrible. He's the most likely candidate. By the way, when they finally got in that house, there was gas smell everywhere, and they got inside and there were 2 dead bodies, Carrie and Lexi, on the bed upstairs. Regional. In this case, around the house, the car was in the driveway, the curtains were drawn, the locked door in the back, the closed windows, all of those things were not normal. They called for some kind of explanation, not normal. Third, locationally, once they got inside that house, they found the door at the bottom of the stairs, which was never closed. When they got upstairs, after they'd removed the gas smell, they found the door to the bedroom stacked with dirty clothes at the bottom. Carrie never allowed dirty clothes anywhere. Then they found the unlit heater pilot that was stuck up in the bedroom where they wanted the gas to come in and help heat the room. The pilot light was off, but the thing was open for gas. And folks, the one that topped it off is when several weeks later they went down to confer with the gas company. They found out it had been turned off because they weren't using it. 1 week before this murder, Todd went down and turned on the gas. And they presented it as a case. I'm telling you, with that combination of things, and I haven't given you the whole case, you as a jury would have done what the others did and convict him of first-degree murder. Now listen to how he applies that on page 51. We were compelled to examine the evidence of tampering because of one important fact. There were 2 dead bodies on the crime scene. How'd that happen? They became completely convinced that was tampered with. Somebody caused that. It did not happen by any natural causes. In a similar way, when we look at the nature of our universe, the existence of living bodies ought to provoke an investigation. Like our murder scene, there are foundational, regional, and locational conditions demanding explanation. The foundational laws of physics, the regional properties of our solar system, the locational properties of our own planet, all speak to our existence. But did this have to be the case? If circumstances had been just slightly different in Carrie's house, no one would have died that night. The conditions had to be just so in order for the outcome to be death. In a similar way, if circumstances in our solar system and in our universe had been slightly different, no one would be alive today. Conditions had to be, class. Just right. That was very weak. Conditions, class, had to be just right, or you wouldn't be here. That's a fact. So what are some of those conditions? We're going to go very fast here. Laws of nature, physical constants, properties of elements and chemicals. Every one of those deserves 6 lectures. But let me just give you one. The gravitational constant that Newton discovered. We have learned if that constant, listen to me class, if that constant were changed by 1 part out of 1 over 10 to the 35th, you wouldn't be here. because there would be no planetary systems that could support living things. That's one. There are hundreds of things just like that, all of which have to be just right. Thank you, Marilyn. She's my hero up here. There are hundreds of those, class, that all have to be just right. And my question to you would be, if you were my jury, how many coincidences does it take that are miraculous for you to be convinced somebody tampered with this? This didn't come about by natural causes. What about galaxies? We are in a galaxy, aren't we? We're in the Milky Way galaxy, and maybe you know, maybe you don't. It's a very specific and beautiful kind of a galaxy. And we've learned through the centuries that it has to be that kind. There are lots of kinds of galaxies. And now with the James Webb Space Telescope, we can see farther out into space than ever. And we've learned all kinds of new things, class. It's just like in his case in chapter 2. Several weeks later, they went to the electric company and the gas company, and they found out things they didn't know before. We're learning stuff all the time. Folks, the more we learn, the worse the case gets for those who think this just happened by natural causes. So I want to show you something we've learned about the James Webb Telescope's discoveries, because it can see farther out into space than ever. So here we go. I'm going to quote from the NASA document, because I'm about to show you a picture which was the first picture publicly released taken by the James Webb Telescope. And here's what they said about it. Webb's image, the image I'm about to show you on the screen, is approximately the size of a grain of sand held at arm's length. Are you with me? Take a grain of sand, hold it in your fingers, and stick it out here arm's length, and close one eye, and think about how much that grain of sand would block out of the universe. Are you with me? That's how much of the universe we're looking at. Never seen before. I want to make sure you got that. Because the picture I'm about to show you, we had not seen before July of 2022. All right, now I've asked the guys to turn off all the lights. Let me get ready here so I don't stumble. All right, class, I wish we could get those windows darkened too, because you live in too much light, folks. You don't have an appreciation for how much is out there. Should we have any surprise as Bible believers that there are millions and millions of stars? No. God said so a long time ago. But here's a picture that was not seen before 2022. It's called the Galaxy Cluster SMACS 0723. July the 12th, 2022 is when it was released. And what I want you to look at up here is all these globs like this. And you say, look at all those stars. No, class. Those globs are galaxies that themselves contain hundreds of billions of stars. And some of them, like that right there, that's a spiral galaxy, you see it? There's another one up there, more sideways. But most of these aren't spiral galaxies. But there's a lot of galaxies here, class. Look, the James Webb Telescope has uncovered millions and millions of stars we never knew about. There's lots and lots of galaxies and stars. So, let's get the lights back on now, if you would. What evolutionists say about that, of course, is, well, think about all those places. You surely must know there's lots of places where civilization exists. There's got to be planetary systems everywhere. And Carl Sagan would have told you, were he still alive, it's almost a certainty of one that there are civilizations in our Milky Way galaxies by the thousands. Why do you think there was all this? Did you see E.T.? I mean, it was a big deal in the 60s, 70s, and 80s. Not anymore to that degree, because the more we learn, class, the less likely it is that there's life anywhere else. than right here. You got to have the right kind of galaxy first. And it's become very clear that it has to be a spiral galaxy. Not elliptical, not irregular, not Seifert, not any other kind. It has to be a spiral. But that's not all. If you look at the spiral galaxy sideways, it has a big bulge in the middle. And if you had our solar system sitting anywhere in here, folks, it would just disintegrate. There'd be no life there. It wouldn't work. There's too many forces working against you. So we've learned that it needs to be on the outer edges, like right about in here or right about in here. Guess where our sun is located with its planetary system? Right over there. But not only that, there's 6 other things about its location that are very specific and important, and that have to be within a very narrow limit. So in other words, the location of the sun in the galaxy has to be just right. Has to be in the right galaxy, has to be in the right location in the galaxy. What about the kind of star? Well, here's our sun on a relative scale with our planets. Sun's a whole lot bigger than our planets, right? You think that's pretty big. Well, it isn't when I show you the rest. Here's our sun compared to Sirius, the dog star, and Pollux, and Arcturus. And I'm not finished, because what about Betelgeuse and Antares? Where's the sun? Right there. Can you see it? I can't either. The sun in this picture is 1 pixel compared to Antares. Did you also know, class, that there are millions of stars smaller than our sun? So our sun, class, is just right. It's almost precisely in the middle. Not exactly, but close. And its size is not all that matters. It's its temperature. It's the way it produces energy. It's the kind of energy that it gives off. And I have another book for you I want to recommend. Oh, well, I've already said it. In this book about light, he tells you 16 things that are about the heat and the wavelength of light that comes from the sun to us primarily, and how important that is. And it's very narrow, or you wouldn't be here. So there's 6 other lectures right there. But how about the location of the planet? Pretty important. Here are our planets in our solar system. Jupiter, Saturn, Uranus, Neptune, all way too big for any life to be on them. Nobody's looking for life there, except for maybe on some of their moons. Earth, what's this one? Class? Mars? Nope. Closest in size to Earth. Venus. And then Mars and Mercury, and then Pluto. Depends on whether you agree it's a planet. It's still a planet. But how many of those are in the habitable zone around our sun? Anybody know? These 3. We know Earth is full of life. Anybody looking for life on Venus? No, it's a messed up planet. It rotates backwards. It has mostly sulfuric acid in its atmosphere, not good for living things. And its temperatures average 900 degrees Fahrenheit. Forget it. So where are we looking for life? Mars, and a certain gentleman wants us to get there, doesn't he? Mr. Tesla. Well, I will tell you, the evidence for life on Mars is minuscule. And we've got billions of life forms here. Problems. Then there are locational problems right here on Earth. Challenges. It's got to have the proper mass, spin, tilt, the right moon. Folks, we could talk for the next 6 weeks about how important our moon is to living things. Critically important. And how many do we have, class? 1. You know that's unusual, right? Anybody know how many moons Pluto, the tiniest planet, had? Probably not. We discovered 3 more on the recent trip. It has 5 moons. There's no life there. Anyway, there's lots of things. Properties of biochemicals, cell, genetic code, molecular machines. That's tomorrow night and Saturday night. Don't you miss it. We're going to talk about the cell and the amazing complexity of the cell at the nano level. And I'm going to talk about down here, if you think of this being a kilometer, that's 1,000 meters. Deci is a tenth. Centi is 100. Nano is 1/billionth of a meter, or 1/billionth of whatever you put in front of it. Did you know, class, that we now have engineers working at the nano level? If you take a meter, it's about this long, divided into 1 billion parts, and one of those is a nanometer. We can't even conceive of things that small, but we've got folks doing it at the nanometer level. And that's more tomorrow and the next night. So I'm going to close tonight by referring you to Dr. James Tour, professor of chemistry, material science, and nanoengineering at Rice University in Houston, Texas. I was privileged with Marilyn to go meet him not long ago, last summer, and he was quite a gentleman. He is a Messianic Jew. He believes with all his heart that Jesus Christ is the Son of God. He openly expresses that to his students. It's on his website if you want to go look. He will tell you if you want to be a Christian, you must believe that Jesus Christ was raised from the dead. And here's why you should. This man is a world-renowned nanoengineer. He's done amazing things. And he's a believer. Here's one of the things. He's been working on graphene. That's 1 layer thick of carbon atoms. That's impossible, but we're doing it. And one of the things he did was test it out on a mouse. He took that mouse and he sliced his neck, just cut it. His spine was severed. And then he used graphene and some other chemicals and put it in there. And in 20 some odd days, that little mouse had recovered 80% of its ability to move. Amazing. We don't know exactly how all that works yet, but there are amazing things happening in nanosciences. So he and his team were working on this for 25 years, decided surely we need to do something else, maybe a little more fascinating and interesting. So why don't we build a car at the nano level? So they did. You see that car right there? It's wheels, there's axles, and this is a drive shaft. This is rotated that makes it move. That's one molecule, class, and you can race it. Well, that's what you do with cars, isn't it? We just had the Indianapolis 500, didn't we? Did you know, class, that they had the first international nano car race? They did. It was in Toulouse, France, April 28th and 29th, 2017. There were 6 teams, Austria, US, this is Rice right here, there's Dr. Tour's team. And they went from France, Germany, Japan, Switzerland, and one other US university in Ohio. And they were against each other as they raced these little cars. Folks, you can't see this, it's at the nano level. You have to record it on the computer. Okay? You say, well, that's dumb. No, it's fascinating. And I'm very pleased to tell you that when they were finished, the Austria-US team, including Dr. Tours, won by going 150 nanometers in 1.5 hours. That's whipping along, isn't it? That's pretty good for a nano car. And the next best one was Switzerland that went 133 nanometers in 6.5 hours. And the rest of them gave up. This is not an easy thing to do, folks. To make nano cars do what you want them to do. Not easy. And I'm telling you that because I want to close with a point here. Here's a paper he wrote on the first one they built. It hardly worked at all because it only rotated 1.8 revolutions per hour. That means in an hour it went around 1.8 times. That's not going anywhere. But in their next version, this one, they won the race. And it rotated 3 million revolutions per second. So it's whipping around there. And class, you don't know this, but the only difference turned out to be, you see that? That's a 6 ring. It's got 5 carbons and a sulfur. You see it right there? Over here, this one only has 5 carbons. They removed that sulfur. That's the only difference. Did any of those guys know that was going to be the case? No, class, they started over. And they ran all their experiments and did all that stuff over again. And like any good engineers, testing every step of the way, and they ended up with a final product that was way better. Dr. Tour says the nanocars built by Rice University were much smaller and far less complex than the kinesin and dynein walkers and other molecular machines common in every living cell. You're getting tired from sitting there listening to me tonight? You got machines in every cell in your body busy. You better eat your proteins. They're working all the time. And they're way more complex than anything we ever built. The Rice team has been working on nanocars for over 20 years. Every molecular machine in living cells is much larger, at least about 10,000 times, much more complex and much more sophisticated. And here is a taste of how much work, intelligence it took to produce one little nanocar. So your eyes should be glued on the screen. After they won that race, everybody in the race said, "Would you share with us what you've learned?" He said, "Certainly." And he'd already published the paper. And watch. Here's page 1 of the paper. I'll pause a moment and let you take that in. Here's page 2. Somebody put this together, class. I'll tell you how that happened. By natural selection, acting on natural variation over 1 million years. Are you kidding me? Nobody would believe that. But that's what happened here. Intelligence over years worked this out. But this is only the touch of the hem of the garment. Watch. The article he wrote came out in 17th of May, 2017. That's 1 month after he won the race. Notice over here, it had 281 pages of supplemental characterization data. 281, I showed you 2. You want to go home and try to read that? I say it's a reasonable conclusion that nanocars were designed by intelligent human engineers, and in no other way would they have ever come about. Is that reasonable, class? Living cells, with all their thousands of nanomachines, far more intricate, complex, interdependent, and full of digital information, were surely designed by a far more intelligent agent than Dr. Tour, as brilliant as he is. And we call him God. It's abundantly reasonable that he did it. So can Christianity and science coincide? The Bible teaches things were made, cause us to see God. And science says everywhere you look, everything looks like it's designed. There's no getting around that. So is it reasonable to believe in God in this scientific age? Christianity and science agree. It has never been more reasonable than in all the history of mankind. You don't need to be worried about whether science is going to undermine belief in God. It is supporting it amazingly well. And I thank you for your good attention.